so 4-7 is the last section that's going to get covered on your test, the last section in the chapter that we're going to cover, which is transforming exponential and logarithmic functions. So everything that you know about transforming graphs is now going to get applied to logs and exponential functions. That's the only difference, okay? So all the same shifts that you've known, your vertical translation, horizontal, vertical stretch or compression, horizontal stretch or compression, and reflection, okay, all get applied to now logs. So if I add after the log or I add after the exponential function, it's shifting it up or down. If I add inside parentheses for the log, so it would be written like this for horizontal, log x plus 6, where it's inside the parentheses, that's going to be a horizontal translation. If I add in the exponent of an exponential function, like if f of x equals e to the x plus 6, that's your horizontal translation. So whether if it's a log, it's inside the parentheses. If it's an exponential, it's inside the exponent. Vertical translation with the log would be log of x plus 6, so not in parentheses, it's separate from it. That's going to be vertical. Or e to the x plus 6 after the exponent would be a vertical. Okay, so inside the parentheses or inside the exponent are the horizontal, outside are the vertical. Okay, stretch and compression is on the front. So if I put a 2 here, that's a vertical stretch of 2. If I put a 1/2 in front of the e, that's a shrink or shrunk by a half or compressed by a half. If it's inside the parentheses or inside the exponent, so if I had, let's say, 1/5 here, remember it's the reciprocal. So that would be a stretch by 5. And if it was in the exponent up here, again, that would be the reciprocal. So this would be a compression by 1/5. And then the reflection, if the negative's on the front, it flips it over the x-axis. If the negative is inside the parentheses or inside the exponent, it flips it over the y-axis. So it's going to flip it from left to right. So the good news is you're not actually, on your test, you don't have to graph these. You do have to describe the transformation if I gave you the equation, and you have to write the equation should you be given the transformations. That's what the two things that you're going to be asked to do. So this is making the table. So should you have had to actually graph it, I would have made the tables. And then it says describe the asymptote, tell how the graph is transformed from the graph of the function. So start with the description part first before we even plot the points. If my function is g of x equals 2 to the negative x plus 1, what's the negative on the exponent do? It's a reflection over the x or over the y? Over the y, right? So this is going to be over the y. If it's in the front, it's over the x. If it's in the exponent, it's over the y. And then the plus 1 does what? Up 1. Okay, so now let's actually plot some points. So if it's negative 3, so this would be 2 to the negative 3 plus 1, which becomes 2 to the third plus 1, 8 plus 1, which is 9. To the next one. And you're going to have your calculators for these, but you can do them without. Negative 2 plus 1. Opposite of negative 2 becomes positive 2 plus 1, which is 5. And then negative 1. 2 to the negative 1 plus 1. 2 to the first plus 1, which is 3. 0, 2 to the negative 0 plus 1 is still 2 to the 0, and anything raised to the 0 power is 1. 1 plus 1 is 2. 2 to the negative 1 plus 1 would be 1/2 plus 1. 1 and 1/2. And then 2 to the negative 2 plus 1, 1/4. 1 over 2 squared, which is 1/4, and 1 and 1/4. And then I want to plot my points. So negative 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be all the way up here. negative 2, 5. 1, 2, 3, 4, 5. Negative 1, 3. 0, 2. 1 and 1/2. 1 and 1/4. So if you think about your typical e to the x function or exponential function, if I were to graph an exponential growth function, it would have looked something like this. So I flipped it over the y, so it's now facing the other way. And I shifted it up 1, which makes sense. So everything that we talked about the transformation happening, it actually happens when you plot your points. There's an asymptote on these graphs. So there's an asymptote. Normally it's at 0, and this one shifts up 1 place so that it's at y equals 1. So just be aware that it's there. A lot of you, when you graph, tend to just like keep going with your points down here. Okay, these points are never going to get below 1, so there should be an asymptote there. So the question is, again, should you or would you be able to describe the transformation or give the function transformation? Okay, so I'm going to skip this one for now. Let's just talk about the transformations, and then if we get time, we'll come back and graph it. Okay, so let's just talk about what the transformation would be here. So that negative 2 in the exponent does what? It's horizontal. So if it's in the exponent, it's like it being in the parentheses. That's when it's horizontal, right? So this would be a right 2. Okay, just so you can get an idea. And again, we'll come back. But you're not going to be having to graph them on your test. Okay, so now let's talk about the transformation. So the negative on the x is causing what? Which would be over the y, right? So this is a reflection over the y. If it was on the front, it'd be over the x. If it's on the exponent, it's over the y. And then the plus 1, and this is in the exponent, which does what? Left 1. If it was after the exponent, so if it was full size, that's when it's that vertical shift. So you should be able to tell if it's in the exponent or if it's not, and if you are unsure, you can always ask. Okay, so all of that was based on exponential. It's exactly the same for a log. So log, again, if it was after the log itself, not in the parentheses, then it's going to be a vertical translation. If it's in the parentheses, it's a horizontal one. If it's on the front of the word log, then it's a vertical stretch or compression. True to what it is, so if it's 6, it's a stretch. If it's half, it's a compression. Horizontal would be inside the parentheses with the log, like this one. And this one's always the reciprocal. So that would be a stretch by 5, and this would be a compression by 1/3. And then reflection, just like with exponential, if it's on the front, it's over the x, and if it's inside the parentheses, it's over the y. So same exact rules, it just now you're dealing with a log. Okay, so let's talk about what the graph looks like first, and then we'll actually graph these points so that you can see it, so you can get that visual. So if it just said to describe how it's transformed, what's the 5 on the front doing? It's a vertical stretch, right? By 5. What's the minus 2 doing? Down 2. So it will be in parentheses if it's left or right. It would be like that if it's left or right. So if it's not in parentheses, it's a vertical shift, which in this case is down 2. Okay, so now let's plot some points. So let's do the same. Let's just do negative 2, negative 1, 0, 1, and 2. So we can see what this would look like. So this is 5 log base 10 of negative 2 minus 2. So what do we, well, I'll let you discover it. What happens when you do log of negative 2? Okay, remember we can't find the log of a negative number. So there's going to be no points, and you can't find the log of 0. There's not going to be any points until we get to log being 1. So I'm going to add additional points on the end, okay? So you discovered if you went to graph it on your own. So I'm going to do log of 1 minus 2, so 5. Log of 1 would be 0 because log base 10 of anything, or log base anything of 1 would be 0. Minus 2, and I get negative 2. And then I'm going to do 5 log base 10 of 2 minus 2. And I get negative 0.5. And then 5 log base 10 of 3 minus 2. God bless you. And I get 0.38 or 0.4. So if I were to just plot those points, 1, negative 2, 2, negative 0.5, and 3.4, they would be fractions, right? Because if your base is bigger than the large number, you're going to have to be putting it in fraction form. So log base 10, if you just did log base 10 of 2 in your calculator, you get 0.3, because you're saying, like, what power can I bring 10 to get to something that's less than 10? So it would always be a fraction, which is going to be a decimal, okay? So the rule on the logs is they take form something like that. So if I had an exponential function and I shifted it, flipped it over, okay? And this time with logs, so with exponential functions, the asymptote is horizontal. With logs, they're vertical. So there's actually a asymptote here that's vertical, okay? So again, just be aware that that's kind of the shape it would take, all right? And then just be able to describe the transformations based on the equation. So this, I mean, the good news is that the graphing portion is not in your test, but obviously, if you needed to graph, you could always plug in your points. All right, so again, let's just describe the transformation. So this time it says ln. What is ln? Log of e. So does it take on all the same characteristics of every other log? Yeah. So this is going to be a general shaped log that would look like this with my transformations. So the negative x inside does what? Over the y. And the plus 2 inside the parentheses is a left 2. So it would be shifted left 2, and it would be turned over the y. Questions on that one? Okay. Last one is now working the other way around. So if I gave you the transformations, you give me the equation. So A says 4 to the x is reflected across both axes, and that should be an I, and move 2 units down. So across both axes means what? There's 2 negatives. There's a negative on the front of that 4, and there's a negative on the x. So if it was over the x, it'd be only on the 4. If it was over the y, it'd be only on the x. And then move 2 units down means what? Good. Minus 2, but not in the exponent. So in the exponent is the horizontal. After it is the vertical. Questions on that one? Okay, and then log of x is translated 3 units left and stretched vertically by a factor of 2. So now I'm starting with log of x. 3 units left means what?
Minus 3.
Good. Minus 3, or sorry, plus 3. Yeah, inside the parentheses. And stretched vertically. If it's vertically, does it go on the front or does it go inside the parentheses?
In the front.
On the front. And it'd be true to what the value is, right? If it was horizontal, then I would do the reciprocal inside the parentheses. Questions? Okay, so we're done. So that's all the material that's going to cover on your test on Friday, which means we get to review tomorrow and Thursday, which is hopefully, well, that's my goal, so I'm glad we got it, okay? So